All right, welcome to the second part of section 1.6. We're going to talk about angles of elevation or depression. The angle of elevation from point X to point Y above X is the acute angle formed by a ray XY and a horizontal ray with the endpoint at X. So here is the diagram of that. There is my horizontal ray, endpoint at X going horizontal. Y was above X up there in the upper right hand corner, made an angle with that ray, so therefore that's my angle of elevation. So angle of depression means now we're going in a downward position. So my horizontal is the same, but now point Y is below X. And this is a common made mistake, is some authors accidentally put this arc going in the wrong direction. It should still go in a counterclockwise direction. If we have the arrow going this way, that would represent a negative angle direction. So watch your arcs. All right, example, finding the length given the angle of elevation. So Pat Porterfield knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 5.3 feet above the ground, find the height of the flagpole. We need a picture with Pat in it. So there's Pat down there in the lower left-hand corner standing there. She says, okay, I know that when my line of sight, my eyes are at 5.3 feet above the ground, that's your horizontal, her line of sight hits the top of the flagpole. And this happens when she's 123 feet away from the flagpole. And her angle of elevation is 26 degrees 40 minutes. And again, her eyes are 5.3 feet above the ground. So we're going this far up the pole. So the remaining distance, we'll call that X. So my height of that flagpole is to add those two together. So we'll say H equals X plus 5.3. Well, the hypotenuse was not given here, so sine and cosine are ruled out. We're going to have to go with tangent. I have opposite side X of my given angle over the adjacent side of the given angle. So we'll go tangent of 26 degrees, 40 minutes equals X over 123. Multiply that 123 to both sides, and there's my calculator entry. We get 61.77292175. Here, the decimal rounding could be confusing. Here we have a whole number. Here we have one decimal place. So I went to two decimal places, 0.77, added the 5.3 to that. We get 67.07 feet. If they tell us otherwise in my math lab, we'll round accordingly. Example 4, finding an angle of depression. Mark this one down as a sneaky question. These are always sneaky. You got to be careful. From the top of a 210-foot cliff, David observes a lighthouse that is 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. So here's David at the top of the cliff. Notice he's not at the edge because his line of sight has to hit the corner of the cliff. So he sees straight down to the base of our lighthouse. This is my theta angle right here. My height of the cliff is 210 feet. I'm 443 feet away. Now, be very careful. Here's where you're going to make your mistake. You're going to solve for a theta and think you have the right answer, but it is wrong. My angle of depression, here's the horizontal at Dave's feet. Here's my angle of depression, this angle right here. So we're going to have to find, if you will, a theta prime. So once we find this angle, we'll subtract it from 90 degrees because these two are going to be complementary. So again, no hypotenuse. We're going to have to go with tangent of theta is equal 430 over 210. If you want to cancel zeros, you're more than welcome to. So the inverse tangent of 430 over 210, or 43 over 21, will be 63.97. Okay, to me, that's close enough to 64 degrees. Take that 64, we'll take it back up here, subtract it from 90. Let's find its complement, 26 degrees. That is my angle of depression. All right, that's always going to happen. Angle of elevation, that angle is usually part of the right triangle we want to work with. Angle of depression, very rarely is it going to be the angle that we build our right triangle in. Bearing. There are two methods for expressing bearings. Okay. One is to use a single angle measure, start with the due north line, and always go in a clockwise direction. So if I wanted to sketch 164 degrees, I make my north, south, west, east. Hey, that's the XY coordinate plane. Start on the positive y-axis or the north line. Go 164 degrees in a clockwise direction. There's my bearing. 300 degrees, same thing. Start on the north line. 90, 180, 270. I need to go about another 30 degrees more. There is my bearing, this ray right here. C, purposely chose this problem because it's not going to look right. Find the angles inside the triangle if the bearing of angle A to angle B is 325 degrees. So we're talking about this side. So here at point A, I got to make a north line. Start to rotate 325 degrees. That's 180, that's 270. Okay. So I need to find angle A. It's 325 degrees minus 270 degrees, which is 55 degrees. You might be thrown off with this, only because my triangle is not drawn to scale. So if that's going to bother you, then you want to make a steeper angle for angle A. Angle B has to be complement to A. So 90 minus 55 will be my angle B. That's 35 degrees. There's my two angles. Again, it might look goofy because the diagram is not drawn to scale. Don't let that throw you off. Solving problems involving bearings. Okay, we have a radar stations. A and B are on a east-west or west-east line. It's the horizontal line. 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. So imagine here's a north line, 61 degrees here. So I'm guessing point A is here on the left. Station B simultaneously detects the same plane, a bearing of 331 degrees. Okay, it's looking like this. So let's draw our diagram. Point A to point B, 3.7 kilometers apart. There's a plane up here somewhere. Well, I already know where it's at because I've kind of roughed this out already. So don't put your point C in right away. Here's what we do. Draw your north line, go 61 degrees. In a clockwise direction, draw a line, extend it to above B. That's the safest thing to do. Then draw a north line at B. We'll rotate 331 degrees. Draw that side until you cross the first line, and that's where your point C is going to end up at. All right, so hopefully it kind of looks like we might have a right triangle here, but I don't know. I got to verify everything here. So over here, angle A, which is this angle here, looks like we got complementary angles. So 90 minus 61 is going to give me 29 degrees right here. Over here, 331 minus 270, that's going to give me 61 degrees. So that's this angle right here. Oops, come back here, mouse. All right. Oh, wait a minute. 61 degrees, 29 degrees, 61. Hey, these two are complementary. So that means this is 90 degrees right here. We're looking for the distance from A to C. Okay, let's see. So if this is the right angle, this is the hypotenuse. Oh, we can go cosine 29 degrees adjacent over hypotenuse, or we could go sine of 61 degrees opposite over hypotenuse. Either one of these two would work out great. Multiply the 3.7 over to both sides for either one that you choose. I'm going to work them both out. I'm going to enter them both into the calculator, and dun, 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 notice you get the same answer no matter what. So our distance from A to C is approximately 3.2 kilometers. Again, I went with 1 decimal point because 3.7 was to 1 decimal point. All right, our second bearing technique is a little bit more descriptive. All right, here you start with a north or south line. And then you're going to use an acute angle to show the direction, either going east or going west. So for example, this is north, 40 degrees towards east. This is south, 31 degrees east. South, 40 degrees west. North, 52 degrees west. So the north or south always comes first. East and west always comes second. All right, so let's practice. Find the bearing of a plane located the following point on a coordinate plane. 0, -5. Oh, I'm due south. So there's 3 ways to write this answer. South, 0 degrees east, south, 0 degrees west, or just flat out due south. Over here, 3, 4. Okay, 1, 2, 3, up 4. There's my point. Draw my line. There's my right triangle. 4, 3, looking for a tangent for this theta right here. So the tangent theta of 4/3, let's go the inverse tangent to find my theta. Calculator tells me 53.13 degrees. Oh, wait a minute. That's from the east line going north. Wait. We got to go from north going east. So we're going to need a theta prime. We need a reference angle right here. So we need to subtract 90 minus 53.13, which is 36.87 degrees. So the appropriate bearing would be north, 36.87 degrees east. So again, take your time, make sure you're always starting from a north line or south line going west or east. 53 would be starting east going north, and that's not the way we write that bearing. Example 6, solving a problem using our second method of bearings. Here we go. A ship leaves a port and sails on a bearing of north 47 degrees east for 3.5 hours. It then turns and sails on a bearing of south 43 degrees east for 4 hours. If the ship's rate is 22 knots, nautical miles per hour, find the distance the ship is away from port. Okay, let's see. North going east, so we want to start over here. Let's see, wait a minute. Knots, that's like miles per hour. That's a rate. We need distance equals rate times time, because this is going to find the distance that the ship has traveled. So let's see, our first distance traveled 22 miles per hour, if you will, times 3.5 will be 77 miles. Then we turn and we travel for 4 hours, so 4 times 22, that will be 88 nautical miles. Nautical miles just means it's kind of like the curve of the ocean, if you will, as the planet. So let's put our port down here on an X, Y, or north, west, east, south line. Let's go north 47 degrees east. We draw this line and we know that distance is going to be 77 miles. So here's my ship. Sailing away, sail away. There we are. Boom. There's my trip. In 3.5 hours, we went 77 nautical miles. Then from this point, we chose to go south. Now we draw a south line and go 43 degrees to the east. And our ship now travels a greater distance of 88 miles. So it appears, wow, it just went right past that original horizontal. So, okay, I have some small right triangles here, but not many. Okay, find the distance the ship is away from port. So from here back to point P. This side is 88. So let's see. hoping I can turn this all into a right triangle. Let's see, 47 degrees here. Okay, down to here has to be complementary, so that's 43 degrees to here. Again, this is my distance x that we're solving for. So this right triangle, notice I extended that south line all the way down until it crossed this east line. That makes a right triangle. So 43 here means 47 up here. Wait a minute, 47 plus 43. That's 90 degrees. So that's a right angle. So we have a right triangle. So Pythagorean theorem to solve for x. Okay, x squared equals 77 squared plus 88 squared. Take the square root of that, go to the calculator, and 116.9316039, round it to wherever they ask us to round it to, 116.9 miles, or if you wish, nautical miles. All right, now for the dreaded difficult problem. Right triangles inside of right triangles. These are the difficult ones. So you may need to pause and make sure you understand everything that's going on here. Francisco needs to know the height of a tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. So he's at point A. He then moves back 50 feet. From the second point, the angle of elevation is 22.2 degrees. Find the height of the tree. So what we want to do here is find our two right triangles. There's one of them. Separate it out, relabel it. A, B, C, X, and the 36.7 degrees. Second right triangle is the bigger one here. Move that out. D, B, C, 50 plus x on the bottom, and this is still h with my 22.2 degrees here. All right, have no hypotenuse, so I'm thinking we need all tangents here. So let's look at these two angles. Tangent of 36.7 degrees is equal to h over x. And the tangent of 22.2 degrees is going to be h over 50 plus x. So, unfortunately, here's our problem. We have two unknowns, h and x. But the good thing is we have two equations. This is technically, okay, back to college algebra days, you have a system of equations. So in order to solve for h, I think what we're going to have to do is solve for x first. Find x, and then we can come back and plug it in and solve for h. So here's what we're going to do. I'm going to take x and multiply it to the other side. I'm going to take x plus 50 and multiply it to the other side. However, I'm going to do that on a new slide because I'm running out of room. This problem takes a lot of room. So there's my multiplication of x. There's my multiplication of x plus 50 to the other side. Now, both equations are set equal to h. We're going to use that good old-fashioned substitution technique. I'm going to take one of these expressions that's equal to h and substitute it into the other h. So I'm going to go this way. And there's my equation. Now we have just one variable in there. We need to solve for x. Downside, x is on both sides of the equation, and even worse, it's inside parentheses. So we need to distribute this tangent to 22.2 degrees to both those terms. There it is. Ta-da! Now be careful here because don't make a real good common mistake here. In order to solve for x, all the x terms have to be on the same side. So we're going to subtract this term from right to left. These will cancel out. Do not, repeat, do not subtract the angles. Leave them as two terms. But wait a minute, I need to solve for x. I can only have one x. You're absolutely right. We're going to factor the x out as a GCF. Still cannot combine these two. But now, at least we're down to 1x being multiplied to this binomial, and I think you know where I'm going here. To solve for x and get it by itself, we're just going to divide this entire binomial over to the right-hand side. So there's my answer for x. Okay, now we're going to take this expression. I'm already out of room on this slide. Like I said, it takes a lot of room. But I'm also going to bring this statement back into play. So x equals this, and then we're going to steal and use this again right there. So there's my answer for x. Here's my x times the tangent of 36.7 degrees. Remember, I don't need to know this numerical value. I just need to know what x is equal to. This is what we would consider an exact value. Don't find its decimal because you will round it and you'll alter the answer. So we're just going to take all of this for x and substitute it in for that x. And there is my answer for h. So we need to type all of this into the calculator. So now I probably really want to use my fraction command here. So 50 tangent of 22.2 on the top of my fraction. In the denominator, you do not have to put parentheses around this. Okay? You can just type in tangent of 36.7, close the parentheses, minus tangent parentheses 22.2, close them, and then jump out of the fraction, go times the tangent of 36.7. What happens is when you hit equals, it automatically puts the parentheses around that. Okay? So these two are the same. You don't have to put the parentheses around it. No, I guess it doesn't put them around it. I left them off. If you have an older calculator, it's 50 tangent of 22.2, close parentheses, divided by, then the older 83s, you would have to put the parentheses around it. Okay, so check your calculator, make sure you get this answer, and there's the height of my tree, 45.093 feet. Again, we'll round to wherever they tell us to round. All right, and that takes care of 1.6.